Okay, so when I left you at the end of the last video, we had just gone ahead and created a scatter plot of this data here. Now what we're going to do from here is we're actually going to do a linear, quadratic, and an exponential regression. Now typically you're probably not going to do this all on one data set because it really wouldn't make sense. You'll often find yourself sort of narrowing it down to one or two options and just running one of them. But I'm going to put them all together in this one because the process is really quite similar. So we're looking at our data set here. And again, I should point out that when you're doing this process, when you're doing these regression analyses later on, you often probably won't have created a scatter plot at all. I just showed you how to create the scatter plot so you could get a visual of what was going on. All right, so I'm going to go ahead and do a linear regression first. And the process, I'll go through it 3 times, once for each, and there's really only one difference between them. So to do any regression, you first hit Stat, and then up here you want to go over to the Calculate menu. Okay. Now you'll see a whole bunch of different options here. Number 4 is a linear regression. It says linreg ax plus b, which you'll probably find is somewhat familiar to mx plus b that you've worked with before. Below that you'll see quadratic regression, so that's the other one, or one of the other ones we're going to look at. And if you scroll down all the way to number 0, which is really 10, you will see exponential regression, which again is the third one. So those are the 3 that we're going to do, but we're going to go ahead and start by doing a linear regression. So I hit enter, and theoretically you could just hit enter again here, but if you do that, you're going to be missing out on a lot of what you're going to need. Specifically, the curve will not be plotted if you do this. So what we're doing is we're going to do a linear regression, and all this means is that we're going to take the 2 variables and we're going to try to fit them to a linear model. So if you think back to the variables that we were using in the beginning when we entered our data, you may remember that they were L1 and L2. So the first thing we need to do is we need to identify that we're working with variable L1 and variable L2. So you can see them here where my mouse is hovering. L1 and L2 are both in yellow, so we hit second function L1. This tells us what the independent variable is. In our case, it's time in years. Now we want to use this comma button to separate. So we've said independent variable, comma, dependent variable is L2. So again, that was second function, and then 2. And now what we want to do is we actually want to turn this into an actual function. This is probably the trickiest part of the whole thing. So far we've done L1, comma, L2, comma, and now we need to identify what we want the function that is made up of these 2 variables to be called. So to do this, we hit vars here, and that's essentially, you can think of that as variables. We scroll over to y vars, and what we're going to do here is we're going to create a function. So we want to pick number 1, hit enter or hit 1. And we don't have any functions yet, so we can go ahead and we can call this y1. So what this is going to do is it's going to do a regression on our data, and it's going to try to fit it to a linear model. So it's going to try to take our data and draw a straight line that fits it the best. Imagine drawing a line of best fit through the graph. And then the calculator is going to also go ahead and figure out all the different values for that formula. That's going to be the slope, which in this case is A, and the initial value, which in this case is B. So you go ahead, hit enter. It just takes a quick second, and there it is. It's telling us that our linear regression model is going to be in the form y equals ax plus b. A is 19,621, and b, or the initial value, is 2,688,861. So they're big numbers, but we were working with fairly large numbers in the first place. We were working in the millions, so having values in the millions definitely makes sense. This r squared and r value aren't terribly important yet. All I want you to know is that the higher r squared is, the better fit this is going to be. R squared will always be between 0 and 1. The closer it is to 1, the better fit it is. So if you look at this r squared here, you can essentially look at this as a percentage. So you multiply by 100 to get a percent. So in this case, it fits about 15.8% or 16%. So that sort of gives us an amount of confidence. Now obviously 16% is not very high, so this data does not seem to be very linear. What I'm going to do next is I'm just going to write out what this function would look like just so that you can see that. Okay, so I paused it there for a sec just so I could write the equation, but here it is at the bottom, and you can see that I've also rounded each number just to take out the decimal places, because really, if we're talking about almost 3 million, I don't think we need a decimal place. It also doesn't really make sense for a number of people. So my equation here, y equals 19,622x plus 688,862. Now, if we wanted to give this a little bit of context, we would remember that our dependent variable was, what was it, number of crimes? I think I said population a few times, which obviously is wrong. And in this case, this was the time in years since 2001. Okay, so there you go. There is our linear equation of best fit. And you'll notice that the initial value here, 2,688,000, does not match up perfectly with the initial value that we actually had. And that's because the linear model has been fit the best that it can, so it's not necessarily going to have the same initial value. And if we actually go ahead and click graph again now, by turning off the second function, we can see the line going through, and what you'll notice here is that where it crosses the y-axis is not the same place as the original initial value. So the fact that this initial value is higher actually makes a lot of sense. So I'm actually going to go ahead and stop the video here for the linear regression because it's almost 7 minutes at this point, and then I will do the quadratic regression separately.